By this point, you've learned about the importance of high-quality information and to read about different data entry input controls that can help prevent issues like incomplete or inaccurate data. But sometimes errors and inconsistencies can still manifest in our data despite these controls. So one useful skill is knowing how to profile your data. Instead of simply scanning over all the values manually, you can use options within Power Query to quickly observe the distribution of values for a given field. Not only might we do this to ensure the quality of our data, this can be part of the analysis itself, a data exploration exercise. So let's practice doing some data profiling with the following hypothetical example. You have been asked to analyze the sales data, consisting of 2,800 records, for a retailer located in Arizona. Prior to your analysis, you decide to profile the data to verify its quality. You have been given the following background information. Number 1. Each transaction should be uniquely identified with a distinct sale ID. The retailer has 6 locations, the newest one having been recently opened in 2025 in Santan Valley. Next, we're told that most transactions are going to take place between customers who walk in and out of the store and are never identified. However, the company has recently started accepting online orders, which requires customers to set up an account. Thus, we are able to track the identity of the customers for those online orders. Lastly, we're told that these customers can earn points for their purchases and may occasionally redeem these for a discount on a purchase. Apparently, the values that this field should take on is no and yes. So let's navigate back to our lecture template to take a look at this data. So now let's make one more connection to another data set. I know we're starting to get a bunch of different sheets here at the bottom and it's feeling kind of messy, but bear with me as we complete this data profiling exercise. Once again, go up to Data. We're going to find Get Data, From File, and From Excel Workbook. And this time, choose the file titled Data Profiling. There should be only one table in that data set, so we can select it and we're ready to transform the data. Okay, first things first, let's name this something more descriptive. I'll call this Sales Analysis and hit enter. And it's always good to start by familiarizing ourselves with the data set, going through each of the columns and confirming the auto-detected data types. Sale ID is text. This seems to be the unique identifier for each row. That looks good. Store location and customer name, they're also text. It's recognized the date of each sale as a date data type. That's good. Sale quantity is recognized as a whole number, whereas sale amount is allowed to be presented with decimals. And lastly, for discount applied, that's text again for all these no's and the occasional yes. At first pass, this seems to be correct. You may have noticed that underneath each field, there's something kind of like a green bar. This bar is a column quality indicator. It's like an initial step we can take in data profiling. Green reflects that cells in the column do take on values, which reflects the characteristic of completeness, and are valid per the specified data type. If I hover my cursor over the bar for sale ID, we can see that 100% of this column is populated with text data, and this is the case with most of our fields. But we notice that in customer name, we've got this big dark gray bar, and this color means that there are null or empty cells in the column. For some fields, this might be okay, as is the case with this particular column. We knew in advance that most of the time, transactions take place between random customers. They come into these stores who buy stuff and leave, and we never who they were. The only time we see customer name is for online orders, so the fact that roughly 60% of these observations are missing is completely fine. But if we were looking at something like the ID field or sale amount, it could be concerning if we were missing data there. But we can do more than just check whether data is present or missing. There are several view options we can select to help us better profile the data. So let's go up to the ribbon and select View. One very quick side note, you can see that the first button says Query Settings. And this can be helpful if you ever accidentally exit out the Query Settings pane on this right-hand side. You hit the X and say, oh no, where are my applied steps? It's okay, you can go up to View and reopen it with Query Settings. But next, I want to show you some of these data preview options. The first one I want to show is Column Quality. This pretty much displays the exact same information we get when we hover our cursor over the Column Quality indicator bar, like we just barely did. But if you want to have this constantly displayed, you could check this box. Most of the time, I think the color is good enough for me, so I think I'm going to uncheck it again. If you click Column Distribution, it presents a summarized version of each column just below the field name of each. For example, it tells us the number of distinct and unique values in a column, and it's important to know the difference between these two adjectives. Distinct tells us the total number of different values that a field can take on in the data. Unique is something different. This refers to the number of values a field takes on in the data that only show up one single time. Put differently, unique is a subset of distinct. If a value is unique, by definition, it is one of the distinct values in the column. However, even if you identify a distinct value in a column, it may not be unique. Multiple records can take on a distinct value. For sale ID, this is the primary key of the table. We should be able to link back any given detail of a transaction to one particular sale ID. So it's good to see that every single record here is distinct and unique. Store location has 5 distinct options, but none of them are unique. And that is also probably a good thing. If we have a sales record that is unique to a store location, that means the store only ever had one sale. Hopefully they're performing better than that. But at this point, we start to scratch our heads a little bit. Didn't our instructions say that there were 2,800 sales records? And I thought they also said that there were 6 locations, not 5. It's important to realize that for the sake of processing efficiency, Power Query is only previewing a subset of the underlying data set. First of all, the data you see here in the middle is only a small preview. Not everything is displayed. If we keep scrolling down, it will load in more records. But remember, our work here is to build a query. We are coding up a series of actions to take place on the entire data set once we've finished. This is different than making manual changes to the data with each button we press. This is just a preview of what will happen based on a sample of data that is originally displayed. Similarly, when we are engaged in data profiling, Power Query is still trying to be efficient. So by default, and as it says here at the very bottom, follow my cursor, column profiling is only based on the first 1,000 rows of a data set. It's not that big of a difference for a computer to scan over 3,000 rows of data versus 1,000, but what if we are working with a database with millions of records? I mean, a single sheet in Excel can only handle a little more than 1 million rows of data max, but Power Query can connect to alternative data sources with more than just a million records. The limits here are basically your computer's RAM. So that said, the default option, as shown right here, is to profile only the first 1,000 rows. And hopefully that's enough to give you a sense of what columns are like. But if you need to do a comprehensive analysis, we need to click this and select column profiling based on entire data set. So in terms of processing, it's not going to be a big deal with the data set we're working with, but be aware that as your data grows quite large, this can slow some things down a little bit. But anyways, looking at the top again, this feels better. We now have all 2,800 records, and we now see that there are 6 distinct store locations. The histogram contained here shows the relative frequency with which the first several distinct values occur in the data. So this little bar here at the bottom, this must be Santan Valley, the newly opened store location. We can see that customer names duplicate, and that makes sense. These are probably repeat online purchases. Let's make our way over to sale amount. And we've now got a red column quality indicator. Well, if I know my cultural context with these colors, I might assume that red is bad. If you have trouble remembering, just think of university colors. UVU, green is good, red, it might mean something else. Red is the color that Power Query uses to say that there are errors in the column. I hover over it, and it says that there are 4. There can be a variety of reasons you could see an error. I think the most common is a data type mismatch. For example, say we try to convert a field into a date data type, but somewhere someone had misspelled a month name. Power Query wouldn't be able to convert that. So it would convert the values that were okay, but return an error for the misspelled date. You might see things where you would use a function incorrectly, or if you divide by 0. Like I say, a variety of issues could create an error for values here, but the most common one you'll see is invalid data types. We'll investigate this soon. We also see that the discount field might have issues as well. Why is it taking on 4 distinct values? I thought this was just supposed to be yeses and nos. Well, I can click this drop down arrow here. It says list may be incomplete. Again, that's based on the top 1,000 rows. Let's load more. And we see that there are also Ys and Ns. We haven't seen these options before. Let's test one of them out. I'll unselect all, and let's just look at the Ys and hit OK. At this point, pause the video and look for any patterns in what is displayed here. It seems very probable that this Y is what's causing all of these errors in sale amount. Another thing you might have noticed, these are all taking place in Santan Valley. In fact, if we go back a step, let's hit the X here next to filtered rows. This time, I'm going to filter based on store location. So we'll click this drop down. Once again, the list may be incomplete, load more. I only want to look at Santan Valley to see if this is a sometimes or an always issue at this store location. After imposing this filter, we can look at the discount applied field. And as it turns out, every single one of these is either a Y or an N. So this explains the story a little bit more. It doesn't seem like there's one single employee who is screwing this up. This seems to be a store-wide issue. Additionally, we see that the errors only correspond to Y values for the discount. In other words, this data inconsistency doesn't appear to cause issues for the sale amount if no discount was applied. Let's try again with another approach. So once again, go to your applied steps. Let's hit the X next to filtered rows. And if I want to filter the data to only show records with errors, I'm going to go up to sale amount and click it. I'll go to the home menu, and under this reduce rows pane, I'm going to click keep rows. Now this does force you to do a drop down, and I'm going to select the very bottom option, keep errors. This is perhaps a more direct way of identifying those records that are creating issues. But now that we're aware of the issue, we can alert the company's management and tell them that this issue exists. But if we want to proceed with our analysis, we might want to drop these records for now. So let's backtrack one more time, getting rid of our current filter that says kept errors. This time, I want to remove rows with errors. We could do it with this button here at the top, but this time I'm going to right-click on the sale amount column header and go down to remove errors. And notice we're back to a solid green bar. And now we have 2,796 distinct records. We've removed those 4 errors. The last profiling view I want to show you is column profile. So let's go back up to the ribbon and click view. I'm going to uncheck column distribution and check the box for column profile. Now, anytime that we click on the column header for a given field, it will give us this additional information. I would say that this view option essentially has the same exact information as distribution, but more. It does take up this big old section at the bottom, so that's basically your trade-off. Let's start by clicking on Store Locations header. And now it shows us that there are now 2,796 records, like we saw before. None of them are empty or have errors. We see that this field takes on 6 distinct values, though none of them are unique. There's also this min and max, which may seem weird for a text variable, but this just shows the first and last value alphabetically. To the right, we've got this value distribution, the relative frequency with which each value appears in the data. It looks like Mesa is most common. We can hover over it and see that the count of Mesa records is 606, which constitutes roughly 21% of the data. We can do this with customer name. Let's go up and click that one, which this time shows the exact number of empty or null values. It looks like James Rich is our most loyal customer with 6 sales. It's kind of funny. I used a random name generator to come up with these names. And of course, the person with the most purchases has the last name of Rich. When you select numeric data fields, like sale quantity, it will also calculate, scrolling down here, the average and standard deviation of these values. We can see that the mean number of items purchased per order is roughly 15, but now that I look at the min and max, I'm surprised to see that some sales have negative 33 as their quantity. Looking at this value distribution, I see that there are other instances, although rare, where negative numbers have been selected. It seems like we have another data entry issue, and thus another recommendation for the company's data entry input controls. A basic sign check here could prevent errors like this from getting into the data. One final thing to point out, you'll notice that this column still has a solid green line for its column quality indicator. And this is because Power Query was expecting only numbers to be here, given the data type, and all that existed here were numbers. So we can't just look at this column quality color and say, oh, it's green, everything is fine. Errors can still exist, hence the importance of carefully profiling your data set, particularly for important fields. Lastly, let's look at sale amount. If the variable is continuous, not just integer numbers, it's way more likely that you're going to have a distribution like this. We've only got a few thousand sales. It's less likely that we're going to have identical values for total sale amount compared to, say, Walmart that processes millions of transactions every day. But there you have it. This is a solid primer on data profiling in Power Query. Hopefully, data entry input controls have been put in place to prevent issues from creeping into our data. But if not, we now have data profiling skills that can help us identify errors. Additionally, we've seen that data profiling can help us just become more familiar with the data as an explorative process. So at this point, to get credit for lecture, let's go back to home, close and load this data, and just save the file, and you're ready to upload this to Canvas for full credit on this assignment. Thanks for your participation.